Assalamu alaikum warahmatullahi wabarakatuh. This presentation will showcase the project of sensor-based automatic Hajj and Umrah Tawaf and Saie detection.
For Muslims, Hajj, one of the five pillars of Islam, is a mandatory religious pilgrimage in Mecca that all physically and financially capable people must perform at least once in their lifetime. Hajj is done starting from the 8th day to the 13th day of the 12th month of the Islamic calendar. Similarly, Umrah is a religious activity that can be performed at any time of the year.
Umrah and Hajj share two common rituals. The first shared ritual is Tawaf, where pilgrims walk counterclockwise 7 laps in the area around the Kaaba, which is the black cubic building that Muslims use as a direction to pray toward as shown in the video. The second shared ritual is Saie, where pilgrims walk back and forth 7 times between the Safa and Marwa hills as shown in the video.
Every year, millions of Muslims perform Hajj and Umrah, yet the data that is collected is mostly general and limited to the total number of pilgrims entering the Haram as shown in these statistics. This leaves room for potential improvement and increase in the quality of experience for pilgrims. This project designs a mobile application that can detect when pilgrims perform completed laps of Tawaf and Sa'i, which can potentially accurately measure the number of pilgrims performing Hajj or Umrah and provide important statistical data that will help improving the experience and management of pilgrims.
The plan for the project is to aid the pilgrims and the Ministry of Hajj by meeting the needs that arise when considering the Tawaf and Sa'i rituals and how can they be optimized and coordinated more effectively. For the guidance, both the Tawaf and Sa'i areas have multiple floors to perform the rituals in. Pilgrims, whether they are an elderly, adult, or young, move with different speeds, and having multiple people with varying speeds in one floor may disturb the movement and cause congestions, especially for the case of elderly. The accurate data provided by the mobile application allows for useful information to be utilized, like which areas are crowded the most, or which time of the day do most people perform Tawaf and Sa'i, and many more. By collecting and utilizing such data, it is possible to guide and assign pilgrims to different floors to perform Tawaf and Sa'i rituals to reduce congestion. Additionally, the pilgrims can be notified by the mobile app with relevant religious text depending on the ritual they are currently performing.
The project was implemented in 2 stages. The first stage is divided into movement tracking of pilgrims and ritual detection. The second stage is deploying the previous 2 into a mobile application.
After researching multiple possible positioning methods, the indoor positioning using sensors proved to be the most practical approach to our project. As for the first step, the application tracks the movement of the user using the phone's inertial measurement unit sensors, mainly the accelerometer, the magnetometer, and the gyroscope. First, the accelerometer is used to monitor the changes in the acceleration of the user, and based on that, an algorithm will detect if the user has taken a step by calculating the pitch angle. Each red dot in the plot represents a step. Once a step is detected, the orientation sensor, which is a virtual sensor that combines all 3 main sensors, will measure the heading direction of the user, which in this case is the azimuth angle. Knowing that the user took a step in a certain direction, the path of the user can be tracked. For the second step, the project first tested an algorithm that used the Fourier transform on the position data of the user to change the data from the time domain to the frequency domain and then observe the frequency duration product to obtain the number of laps. Although the results shown display the actual number of laps, this method was rejected since it cannot detect laps in real time, which is a main point of the application, and it also can result in error in the case of varying lap speeds. For the use detection method, the team designed an algorithm named unknown center of rotation. While the path of the user is being tracked, the current position and the previous path of the user will be fed into an algorithm that will use this information to build a relative center of rotation and analyze the path taken to detect if the user is doing Tawaf, Sa'i, or neither. If Tawaf or Sa'i is detected, the algorithm will keep track of the laps taken regardless of the shape of the laps as shown in these demos.
After completing the previous 2 steps of the first stage, the second stage is app programming. The mobile app has Google Maps API that can detect whether the pilgrim is in the Tawaf and Saie areas or not. Then the previous two steps, movement tracking and ritual detection, were originally written in MATLAB. Therefore, they had to be translated to Dart programming language, which allows the app to be deployed in both platforms, Android and iOS devices.
For the prototype, we designed an application named Ashwat, which is the Arabic name for the labs in Tawaf and Saie. First, for the Saie demonstration, one of the team members is taking Saie laps going back and forth between 2 points, and on the right is the recording of the phone screen displaying each completed lap. The parameter of the distance of the Saie algorithm has been changed to 2 meters only for the sake of this demonstration. It can be changed to any value. Now, for the Tawaf demonstration, similar to the Saie, the parameter of the radius of rotation has been changed to 1 meter only. The video shows different angles and how the phone looks like when completing the laps from the user point of view. For both Tawaf and Saie, the phone notifies the pilgrim when all the 7 laps are completed. These notifications can also be set to be at every lap. While the user is performing the Hajj or Umrah rituals, the application will notify the pilgrim and provide relevant religious text based on the activity and the location of the pilgrim. Additionally, the project aims to support numerous languages spoken by Muslims around the world. The application also stores the X and Y coordinates of the user and their respective time. Here's an example of the coordinates in 2 laps, with each position having its respective time. Based on that, the speed of the user can be measured in any instance, which allows for congestion detection.
Saudi Arabia already have mandatory applications such as Tawakkalna. This fact can ease the process of the adoption and can allow the project application to potentially be mandatorily installed in pilgrims' phones, which will increase both the number and accuracy of data. This application has a high potential to improve the Hajj and Umrah experience for both the pilgrims and the Ministry of Hajj.
We hope you enjoyed our presentation, and thanks for your attention.